Values delta TF is equal to KF, weight of solute upon molecular mass into 1000 upon weight of solvent. Delta TF is 0.17, KF is going to be 5.16, solute is 0.2 gram, 1000 is a constant, solvent is 100 and MB is your question. We can calculate the value of MB and this value comes out to be 60.70. 60.70 is the answer. There is molecular mass of solute. There is question number 11. Option valid is C option. Now we move on to question number 12. Which of the following represents correctly the change in thermodynamic property during formation of 1 mole of an ideal binary solution? This question is related with the thermodynamic aspect of ideal solution. In case of ideal solution, question number 12, thermodynamic is ideal solutions. For ideal solution, delta H mixing is always equal to 0. There is no change in the enthalpy of mixing. But they are spontaneous mixings. Therefore, delta G comes out to be negative because spontaneous solution formation. Solution is formed at its own, spontaneous mixing is there. It means delta G must be negative. For delta G to be negative, delta G is delta H minus T delta S. Delta H mixing here is, this is delta S mixing, there is delta G mixing. As this is 0, minus T delta S mixing, and we have delta G mixing. It means when delta G mixing is negative, 0 minus T delta S, minus and minus cancelled, that means T delta S should be positive. So graphically we have delta H if a straight line, T delta S should be positive and delta G should be negative. This type of graphs are given in your question joule per mole. Here it is negative written, positive written, this is 0 value. So we are having graph valid is C option. C is the correct graph in which delta G is negative, T delta S is positive, delta H mixing is 0. Now question number 13. Question number 13 is normal boiling point of toluene. Normal boiling point of toluene is given to you. It is in given degree Celsius. First you have to convert it into Kelvin scale. Then its boiling point elevation constant Kb is also given. We want to calculate enthalpy of vaporization of toluene. Question is about enthalpy of vaporization of toluene. In this question, when it is 13th question, Kb formula is there. Value of Kb is mR Tb square, Tb naught square divided by delta H vaporization into 1000. This is the formula. In this formula, Tb naught is given to you. Tb naught is given to you as 110.7 plus 273 in Kelvin scale. This value comes out to be 383.7 Kelvin. Now delta H vaporization is given to you as a question. This you want to calculate. It means delta H vaporization is M R 383.7 whole square divided by Kb into 1000. Value of M here is toluene. Toluene is C6H5CH3. Its molecular mass can be calculated. It comes out to be 92. We have C7H8. 12 into 7 plus 8. So we get value calculated. Put the value of M. R used is to be 8.314. into 10 raised to power minus 3. Reason is our options are in kilojoules. This is in kilojoule per mole per Kelvin. This value is to be used. Temperature is in Kelvin scale. Kb is given to you as 3.32 Kelvin kilogram per mole. On solving this, you will get the value of delta H vaporization coming to be 34 kilojoule per mole is the coming option. Option is B, 13th question, beta. Now question number 14 is about a binary liquid AB mixture showing a positive deviation from Raoult's law. This question is about positive deviation from Raoult's law. When we say it is positive deviation from Raoult's law, question number 14 we are going to start. Positive deviation signify. Positive deviation means PA is greater than PA naught XA, PB is greater than PB naught XB, P total is greater than PA plus PB, delta H mixing is going to be positive, delta V mixing is again positive, and forces between A and A, B and B, and after mixing A and B there are weak forces. So we are having stronger forces initially and weak forces after mixing. Weak forces after mixing. Options are A option is PA is less than PA naught XA is wrong. B option is intermolecular forces are stronger initially than that of afterwards. Intermolecular forces are stronger than AB. Right? This is correct option. Intermolecular forces are initially strong, therefore required energy is more. Required energy is more and released is less. Released is less. Process is endothermic. Delta H mixing is going to be endothermic. Delta V mixing is greater than 0. Delta V mixing is greater than 0. That means positive should be the option. यहाँ पे given है less than 0. Then delta H mixing is given to you as less than 0. Again a wrong option. Thus the valid option is B, beta. 14th question, option is beta. It means intermolecular forces are stronger initially and later on they are becoming weak. Question number 15. 14th question, option is B, beta. Now 15th question. Question number 15 is, in any Cl structure all the octahedral voids are occupied, tetrahedral sites are occupied, octahedral as well as tetrahedral sites are occupied, or octahedral as well as tetrahedral sites are unoccupied. In this question you must know the structure of NaCl. It means rock salt structure should be very much clear to you. The rock salt structure should be clear. Rock salt, that means NaCl type of structure. For question number 15 we have NaCl is the example. Cl is having CCP or FCC arrangement, and sodium 1 positive is in all octahedral voids. Octahedral voids are present at, these are present at edge centers, edge center and body center. In case of sodium chloride structure, we are having presence of sodium ion at octahedral sites. All the octahedral sites are occupied by sodium ions. It means your valid option is A, alpha. 15th question, option is A, alpha. Now we have 16th question. Again, it's discussion about rock salt structure. In case of rock salt structure, option A, tetrahedral sites are smaller than that of octahedral sites. It's very much correct. Octahedral sites are occupied by anions. This is wrong because octahedral sites are occupied by cations. Radius ratio is 0.732. Here coordination number is 6. 6 coordination number means radius ratio, radius of cation to anion is 0.414, not 0.732. 0.732 is for cubic void. There is a D option. Anion is having hexagonal close arrangement. That's again wrong. Anion is having CCP or FCC type of arrangement. The option A is the only valid option. 16th question. Option is going to be A alpha. 17th question. Question number 17 is, mole fraction of a solute is 0.4. The relative lowering of vapor pressure is. Now in this question we need the formula of relative lowering of vapor pressure. Question number 17. When we say relative lowering of vapor pressure, lowering of vapor pressure, the formula is PA naught minus PA upon PA naught is equal to XB. This is given to you as 0.4. Mole fraction is given as 0.4. It means relative lowering of vapor pressure is 0.4. That means 0.4 into 100. It is 40%. So we have 40% is going to be the relative lowering. The percentage is 40%. Option is C. 17th question. Option C is the valid option. Now 18th question we are moving on to. In 18th question we want to calculate Vent-Hoff factor and we want to know that Vent-Hoff factor is 3 for which option? Question number 18. We want to know Vent-Hoff factor is 3 for which option? A option is sodium sulfate Na2SO4 with 90% dissociation. Here we have dissociation given to you. It means we have to use the formula of I is equal to 1 minus alpha plus N alpha. 1 minus alpha plus number of ions are 3. It means 3 alpha. It becomes 1 plus 2 alpha is equal to I. I become 1 plus 2 into 90%, 0.9. That means 1 plus 1.8. It becomes 2.8, not 3. Option B is B option. It is aluminium sulfate Al2SO4 whole thrice with 95% alpha. Again I is equal to 1 minus alpha. Now it is 5 alpha. 1 plus 4 alpha. 1 plus 4 into 0.95. Understood is 1 plus 4 into 0.95 cannot be 3. Thus just leave the option. We can't say this is the option correct. C is calcium chloride and it is 80% dissociation. Alpha is 80%. 1 minus alpha plus 3 alpha. It means 1 plus 2 alpha is equal to I factor. 80% means 1 plus 2 into 0.8. It means 1 plus 1.6. It becomes 2.6. Not the correct option. Now the only option left is D delta. It is K4FeCN6. You are given with K4FeCN6. 5 ions are there. It means I is 1 minus alpha plus 5 alpha. 1 plus 4 alpha. 1 plus 4 into alpha is given to you as 50%. 50% is 0.5. 4 into 0.5 is 2. 1 plus 2 is going to be 3. Thus we can say the correct option is D delta. This question 18. option valid or correct is D, delta. Only D is showing 3 as the correct Van 't Hoff factor. Now question number 19. 19th question. Nineteenth is about freezing point. 0.2 molar, that means molality is given to you. Hx is written. Degree of dissociation alpha is 0.3. I factor 1 minus alpha plus 2 alpha. It means 1 plus alpha. It means 1 plus 0.3. 1.3 is I factor. Kf is given to you. Kf is given as 1.86. Freezing point of the solution is nearly equal to TF आपको कैलकुलेट करना है. Formula is delta TF is equal to I KFN. I is 1.3, Kf is 1.86, molality is 0.2. On solving this, we get 0.484. Around this is the value coming to be. It is in degrees Celsius, but this is delta TF. Our question is not delta TF, it is TF. In aqueous solutions, whenever there is aqueous solution, in aqueous solution, delta TF is TF naught minus TF. Delta TF is 0.484 and TF naught is 0 minus TF. So TF always comes out to be minus 0.484 degrees Celsius. You must remember that in case of aqueous solution, delta TF with a negative sign becomes the freezing point. Delta TF with a negative sign becomes freezing point. Next is question number 20. 20th question is 19th question. Your option is now A alpha 0.484. Same option is given as D delta, but it's positive. Your option is negative. So 19th question. Your option is A. Question number 20. 20th is A is edge length of simple cubic, body centered cubic and face centered cubic. Then the ratio of radii of the spheres in these systems. We are having simple cubic, body centered cubic and FCC, face centered cubic systems. In case of simple cubic, 2r is equal to A. In BCC, root 4r is equal to root 3a. And in FCC, 4r is equal to root 2a. R becomes A by 2. R is root 3a by 4. R is equal to root 2a by 4. Now root 2a by 4, this can be rationalized and we get the value of 1 upon 2 root 2a. It means your option is A by 2. First is 1 by 2a. Second option is root 3a by 4. Third is 1 by 2 root 2a. So option A is the one correct option for 20th question. Now question number 21. 21st question is solid structure in which W atoms are at the corners. W at corners. First point given. O atoms at the edge of the cube. O is at edge. And sodium at the center of body. Sodium at center. Body center. Body center is only 1. Therefore it's 1. Edges are 12. There are 12 edges. Each edge is having contribution 1 by 4. Therefore 3. Right? Sodium is at corners. 8 corners. Contribution 1 by 8. It's equal to 1. It means sodium 1. Tungsten W1. Oxygen 3. NaWO3 is the option. C is the correct answer. 21st question, option C. 22nd question. 22nd question is, oxide ions are having CCP arrangement. Oxide are having CCP arrangement. A is present at 1/6 of tetrahedral void. 1/6 of tetrahedral voids. And B is present at 1/3 of octahedral void. B is at 1/3 of octahedral voids. What is the formula? This is our question. When CCP arrangement, the particles are going to be 4, all corners and face centers. Tetrahedral voids are double the number, that means 8. Octahedral voids are same the number, that means 4. 3 2s are 6 and 4 2s are 8. It becomes 4 by 3. This again becomes 4 by 3 and this is 4. It means ratio is to be taken. This comes out to be 1, 1 and 3. Ratio becomes 1, 1, 3. A, B, O3 is the option. A, B, O3. Question number 22. Your option is C. 23rd question. 23rd question is, which of the following has the highest boiling point? Now question number 23 is about boiling point, and highest boiling point is to be known. 23rd question, highest boiling point. Boiling point is directly proportional to number of particles. Freezing point is inversely proportional to number of particles. Boiling point is directly proportional to number of particles. In your options, A option is 0.5 molar calcium chloride. It is 0.5 into 3 ions. It means 1.5 mole are the particles. Then is B option is 1 molar HBr. 1 molar means 1 into 2 HBr, 2 particles. 2 molar is the concentration. C is 100 gram glass in water. Glass is not soluble in water. Thus we can say it's not the option. D is 1.8. D option 1.8 10 raised to power 24 glucose molecules. Again non-electrolyte, but this is 1.8 10 raised to power 24. Let me number of moles. 1.8 10 raised to power 24 divided by 6 into 10 raised to power 23. This will become number of moles. Number of moles are going to be 10 raised to power 23, 24 is 10. It means 18 by 6.02. 6 3s are 18 around. It means about 3 moles. 3 is the largest number of moles. Therefore, this can be the option only. 2 is less than 3. 1.5 is again less than 3. 23rd question. Option is B, delta. Largest number of particles are in glucose solution. 24th question. It is about relative lowering of vapor pressure of 3 solutions. And we want to have ratio of the 3. We are given with NaCl, copper sulfate, NaCl, copper sulfate and sodium bisulfate. Relative lowering of vapor pressure as concentration is 0.1 molar for all, same concentration. Now you can just look at the number of ions. Number of ion here is 2, 2 and 3. Sodium 1, H positive, sulfate 2 negative. Ratio of these is 1 ratio 1.5. It means relative lowering of vapor pressure is going to be 1 ratio 1.5. Beta is the correct option. 24th, beta is the answer. 25th question. What would happen if a thin slice of sugar beet is placed in concentrated solution of NaCl? 25th question is about osmosis. When sugar beet is placed in concentrated NaCl, X osmosis will occur. X osmosis will occur, and due to X osmosis, sugar beet slice will lose water and will shrink in size. तो आपके पास आंसर बना ऑप्शन इज ए. अल्फा इज द ऑप्शन. Sugar beet will lose water from its cells. X osmosis will take place. Question number 26. Fifth question. The valid option is A alpha. Now 26th question we are moving on to. 26th is 1.5 liter of a solution of HCl with normality. 26th question. HCl solution normality N1 is X given. Volume V1 is 1.5 liter given. Mixed with, again HCl is there. Normality is now some other normality. 2 molar is given. Molarity is equal to normality for HCl. Therefore, normality is taken as 2. Volume V2 is taken as 2.5 liters. Resultant solution is having a normality of 5. It means is equal to a HCl solution aqueous. N3 is given to you as 5. What is the value of X? For this mixing, formula is N1 V1 plus N2 V2 is equal to N3 V3. N1 is X, volume is 1.5 into 1.5 plus 2 into 2.5 plus is equal to N3 is 5, volume V3 is V1 plus V2. It is 5 into V1 plus V2 is 2.5 plus 1.5. 5 into 4.0, 20. This becomes 20. Now it is 1.5x plus 5 is equal to 20. It means 1.5x is equal to 15. X becomes 15 by 1.5. Your option is 10 normal. N1 comes out to be 10 normal. Well, correct option 26th question. It is B beta. 10 normality will be found. 27th question. Question number 27. A ternary electrolyte. 27 question A is ternary electrolyte. Ternary means its vent of correction is 3. B is given as non-electrolyte. It means I factor is 1. 0.1 molar solution of B. 0.1 molar solution of B produces an osmotic pressure pi. Pi B is 2p. Molarity of A is given 0.05 molar of A. Same temperature would produce osmotic pressure equal to pi A you want to calculate. Temperature is given to be same in both the cases. We will use the ratio technique. Pi A is equal to IA CRT. CA RT. Ratio of pi B is equal to I factor of B CB RT. RT and RT cancel out. It means I factor for A is 3, for B is 1. C is 0.05, for B it is